So today we'll be talking about integration. We'll be talking about integration. And when we say integration, we say that when we talk of integration, we say integration is the process of finding the expression for y in terms of x when given the gradient function. Yes, so when we talk of integration, it's finding the expression for y in terms of x when given the gradient. So the gradient will be the values that will be given. So for example, we say if dy dx equals to 4x, find y. If you have to find y, then we need to bring the integral sign. So therefore, dy dx will be equal to, dy will be equal to integral 4x dx, which will say that y is equal to 2x squared plus k. It will be explained. All right. So you say that note that k is called constant of integration. So you see, in differentiation, the constant, we don't represent it by any letter. We say the constant is 0. But with integration, we represent the constant with the letter k. So that's why I have highlighted it here. So let's take note of it. Also, integration is the reverse of differentiation in general. When you say, why is it reverse? Differentiation is we subtracting the powers and multiplying the exponent, right? But for integration, we add 1 to the power, then divide the power by the coefficient. That's integration, and that's why we are saying it is the reverse. All right. So the rule can be used to integrate. So this is the rule. If you are to integrate a term, this is the rule. This is the rule. So let's say, for example, we having, for example, that we had 4 divide the x over 4. For example, that we have divide the x over 4 equals to 4x. So if you are finding the integral of y, you say dy equals to the integral of 4x this times this, so we get a dx. The reason why the dx is here is that we did cross multiplication. So we get y to be equal to, we add 1 to the power. The 1 already, 1, x is having the power 1, so 1 plus 1 will give us 2. So we get 4x squared divided by the power, which is 2, plus k, because this one, it becomes k. Good. So this go into this. So you see y is equal to 2x squared plus k. Sorry. 2x squared plus k. That's that. So you see the formula is, or the rule is, you add 1 to the power. Here is it. You add 1 to the power. You add 1 to the power. Then the the entire power divided by the coefficient. So let's look at this. The power over here, the power was 1. And we added 1 to it. making it 2. Then we divided the entire power, which is 2, by the term, which is 2/4. So when we divided, we had 2x squared plus k. It's the same as the rule. The same as the rule is what? Saying. All right. So that's that. So let's have these examples and see. So example 1. Example 1. Before that, let's clean this. Example 1. We have integral of x exponent a dx. Please. Please, let's mute ourselves. So we have x exponent a dx. So as the rule is saying, we add 1 to the exponent. So let's say solution. Solution. Good. So we add 1. Say x exponent a dx will be equal to 8 plus 1 is 9. We will get 1/9. 1/9. My over is big. 1/9 x exponent 9 plus k. That's that. The reason why it is 1 because the coefficient of x is 1. The coefficient of x is 1. So let's take note. So this is the solution to the first question. Then the second question says, integral x dx. Integral question 2. The integral of x cubed dx. We add 1 to the exponent or the power. So we are going to get 1/4. You get it? 1/4 x exponent 4 dx is easy as ABCD. No dx? Yes. x/4, 1/4 times 1/4 x exponent 4 plus k is easy as ABCD. So you have to know that the rule is 1/n plus 1 x exponent n plus 1 plus k. That's the rule. So let's take notes. Let's move on to the next question. The next question says integral x exponent 5 dx. Integral x exponent 5 dx which is equal to 1 over 5, not 5, but plus 1, which is 6. 1 over 6 times x exponent 6 plus k. So that's that. Any question as we are diving deeper? Any question? Any question? Take note that the ones that we did earlier, the ones that we did right now, it didn't have any coefficient. The coefficient that it had was 1. But this time around, the ones that we are about to do, they will be having coefficient. That's why we are representing the coefficient here by what? A. That's why we are representing the coefficient here by A. So integrating ax exponent n, the A represents the coefficient of the x. So let's take note. So that one also, the rule is the same thing, the same rule. You get it? But just that over here, there is a coefficient, and that coefficient is the A that we are seeing here. So if you take this A out, and bring the 1, it's the same as the first rule that we were using. It's nothing different from this. You get it? Just that this one, we are having what? A coefficient. So let's take note. So the first example that we're talking about is integral 2x cubed dx. So integrating ax exponent n. All right. So we are going to get 1 integral 2x cubed dx. 2x cubed dx. So we are going to get solution. Please, let's take note that if you don't understand anything, draw my attention. If you don't understand anything, kindly draw my attention. So you get, you see integral 2x exponent 3 dx is equal to 2 over 4, because 1 plus 3 is 4. 1 plus 3 is 4. Times x exponent 4 plus k. So we get 1 over 2 x exponent 4 plus k. So one may ask, why 2 over 4? 2 can go into itself 1 and go into 4 how many times? 2. So let's take note. And I hope each and every one of us is writing something down. For reference. Then integral, that's the II. Integral 4x cubed dx is equal to, so you get 4 over, or 4 over x 3 plus 1 over 4. So the 4 is the same as 3 plus 1. The 4 is the same as what? 3 plus 1. So let's take note. So you get x exponent 4 plus k. X exponent 4 plus k, giving us our final answer. That's our final what? Answer. That's our final answer. Right, the third question says, the third question says 6x squared dx, integral 6x squared dx, integral 6x squared dx equals to 6 over or 6x 2 plus 1 all over 2 plus 1 plus k. So this will give us 6x exponent 3 all over 3 all over 3 plus k. All over 3 plus k. So you get 2x cubed plus k as our final answer. As our final answer. Let's take notes. So when you are resolving an integration with just a coefficient, you are integrating a term which has a coefficient, you add 1 to the power, then divide the power by the entire term. Yes, you add 1 to the power and divide the power by the entire term. So if you can see this example 1, you see that we have power 3. But when we add 1 to power 3, we have 4. 4 then we divide by the coefficient. And the coefficient was 2. And 4 is a factor of 2. So 2 can go into 4. That's why we had a 5 here. We have the half here. The same applies to this one also as well. 4, we had 4x cubed x. When we are integrating, we add 1 to the power, making it 4. We divided it by the coefficient, which is 4. And 4 can go into itself 1. That's why we had the x exponent 4 plus k. The same applies to this one also as well, that we had 6x squared to integrate. And during the integration, we know that the rule says that we should add 1 to the power, then divide the power by the coefficient. And when we are dividing the power by the coefficient, we had the coefficient to be 6 and the power to be 3. So 6 is divisible by 3. So we had 2 exponent 3 plus k, which is the term constant. All right. So we are proceeding and we are now moving on to integrating a sum or difference of functions. See, it's not always that we get only one term. We're doing integration, it's not always that we get only one term. Sometimes we may get 2 terms to integrate, sometimes we may get 3. So when we get 2 or 3 terms to integrate. Ideally, they count with what? Operational signs. And what are the operational signs that we know? We know that the operational signs that we know, we have addition. We have addition as an operational sign. We have subtraction. We have division. We have multiplication also as well. Yes. So these are the operational signs that we'll be using here. But this time around, we are talking about two. We are talking about two operational signs. We are talking about two operational signs here. We are talking about two operational signs here. So let's take note. Let's take note. The operational signs that we are going to use is addition and subtraction. So let's take the first term. We say that one also, we are using the same rule. We are not changing anything. We are not changing anything. If you pay attention to the rule that I have explained here, you will get to know that this one, it has a coefficient. This one has a coefficient, but this one does not have what? Coefficient. It is telling us that there may be some terms that we may be asked to find what? We may be given a term with two coefficients, or we may be given a term with one coefficient and the another term not getting what? Coefficient. Or we can get two terms which will have what? No coefficient. At the same time, we will have a term which has what? Both coefficients. So let's take note. But always let us not forget about our what? Our constant. Irrespective to the term that you are going to differentiate. When you forget your constant, please, you are working in vain. So let's take note as we proceed with our examples. The first one says, the example one that we are going to take says, so integrating sum and difference. So let me do it sum, which is plus, and difference, which is subtraction. So let's take note. Integrating sum and what? Difference. So the example one, we have integral of bracket open 3x squared plus 5x, bracket open 3x squared plus 5x plus 5x bracket close x. All right. So when we are differentiating, we are using the same rule. The rule says that what? 1 over n plus 1 x exponent n plus 1 plus k, or the term has a coefficient, which is, let's say, a. Then we say a over n plus 1 times x exponent n plus 1 plus k. Do you get it? So with this example that we have here, we have the one term to have what? A coefficient, which is 3, and the other term to have a coefficient, which is what? 5. So we are fortunate enough. We are going to use this. We are going to use this rule. So let's take note. So we are going to get 3 over 3. Because if you add 1 to 2, you are going to get 3. X 3 plus 5. We are having an exponent of 1 plus another one making 2. We have 5 over 2